Right, so quickly, I got this question to find the sum of this series. So I'll start with this. I want to find the sum of this particular series. So if I want to sum this to n, means that when k is 1, I'll put it there, plus when k is 2, when k is 3. But this is going to be kind of very hard to get to the root of the equation. So what I will say is for solution 1, for question 1, I can resolve this to partial fraction. So let me resolve the partial fraction. I'll resolve this to partial fraction. So how do I do that? So this is a over k plus 1, right, plus b over k plus 2. So let me resolve this to partial fraction. So a into k plus 2 plus b into k plus 1 equals to 1. Is that okay? So if k is equals to, if k is minus 1, then this is out. Then minus 1 plus 2, that's 1. 1 times a. So a will be equals to 1. And if k equals to minus 2, this is 0. So minus 2 plus, that's minus b, equals to 1. So which implies b equals to a minus 1. So I'll bring that into this. And this can also be written as n into k equals to 1 over 1, which is our a, over k plus 1, then minus 1 over k plus 2. Alright, so since I have this, I can now put all of this and we can see the beauty of it. Very, very clear. So if I should put 1 here, that would be 1 over 2, because k is 1, that's 2 minus 1 over 3. Then plus, if I should put 2, that's 1 over 3 minus 1 over 4. If I should put 3, that would be 1 over 4 minus 1 over 5. Then it goes on and on to second to the last, is when k is n minus 1. You know, if I want to do n for if I want to do when k is n, that's the last part. So 1 over n plus 1 minus 1 over n plus 2, right? But before that, there is n minus 1. So when k is n minus 1, so I would have 1 over, see, this is n minus 1 and there is a plus 1. So this is going to be 1 over n minus, when n is n minus 1, that will be 1 over n plus 1. Do you get that? So with this, I can cancel out, there's something I can cancel out here. Then this takes out this. See that this takes out this. So obviously something will take out this out and this. So I'm left with the first and the last. So the sum to nth term to this is basically 1 over 2 minus 1 over n plus 2. And that's all we're asked to find. 1 over 2 minus 1 over n plus 2. And it works, basically it works, because if you check, if I want to check and balance, let me see if this is correct. If I want to do the sum of the first two, the sum of the first two, that means when k is 1 and when k is 2, is that I have to put, let me check that. If I have to put k is 1, that's going to be 1 over 2, 2 times 3, that's 6, plus when k is 2, that's 3 times 4, that's 1 over 12. So this is basically 12. 2 plus 1, that's 3 over 12, right? And that's 1 over 4. That's the sum of the first two. If I should try that here, if I should put a 2 here, that's going to be 4, right? So 1 over 2 plus 1 over 4 minus a 1 over 4. So this is basically going to look like 4. 2 here is 2 minus 1, that's 1 over 4. And it's still the same thing with this. So these are our final answer, basically. Just so that's how to solve question 1, right? So let's quickly check question 2. So for question 2, I'll just have to deal with them one after the other. So I will deal with this part of the equation of the expression. This will be a summation of n k starting from 1. So I will deal with just the j, and I will take k to be just dormant, right? So if I have a j there, that's 2 into, because j is just a linear, so it will be n is going to n, it's going to m. So this is n into n, n plus 1 over 2 plus 3k, right? So this is, I got this from the fact that the summation of k starting from 1 to n is n into n plus 1 over 2. So that's how I got this from. Then this cancels this, then I'm left with the summation of now k starting from 1 to m, and I have this n squared plus n then plus 3k. Now meanwhile, I wouldn't just leave this one like that because it's a constant in this case. So I'm going to add a n to it. So this is going to have an n, because the summation of a constant in this case is summation of a constant is just cn. So that's how I got this. So I'll do with respect to k now. So k, these are constants. These are constants now. So they are going to be having n squared m plus nm then plus 3n into, then to m is m into m plus 1 over 2, right? So same procedure and same step. So this is what I have. So this cannot cut this, so I can either leave it this way or do some further simplification. So that's how to do the sum of this one and for the first one. So don't forget to like, share and subscribe to this channel, and I'll see you in the next video.